Assalamu alaikum wa rahmatullahi wa barakatuh. My name is Al-Dailami. I'll present my FYD2 project, which is Arabic speech recognition using neural network. My supervisor is Dr. Emilio. Abstract. Speech recognition is a great technique to make the interaction and communication between machine and human is the Arabic language is occupied a high rank in terms of the number of spoken people. And this project deals with a real data set to predict Arabic word based on duration of the word. And the used model are recurrent neural network and deep neural network. Problem statement. Regarding several resources, it can be summarized the problem statement in 3 points. The first point, people who suffered from communication disability do speech therapy and cognitive exercises. Speech recognition may be one of the most important means to assist these people to solve their problem. The second point, there is a big obstacle while associating with atomic speech recognition. And this is because the talker, and this is because the talker dialects, the variance of background noise, and the crosstalk. And the third and last point, the market highly demands speech recognition techniques, and especially with big companies such as Google, Amazon, Microsoft, to use this technique to improve their smart product. Objectives. We have 3 main objectives. The first one is to design a method to convert speakers' sounds wave to text based on deep learning. Second, to develop algorithms using neural network and NLP to recognize Arabic words. Third, to evaluate the performance of the algorithm. And for the significance of the project, converting Arabic speech to text, helping people to learn Arabic language, facilitating communication between machine and human, and enhancing other application performance, such as translation apps. Methodology. We have 6 stages in methodology. Start with data collection, data preprocessing, data tokenization, modeling, visualization, and testing. To drive depth in methodology and explain everything in detail, I will show the coding for that. First of all, for data collection, it can be seen this is one symbol of data collection, and we have more than 1,800 files. And all these files, it's look like this. The most important things in this file are the 4 things: the interval, the xmin, the xmax, and the text. We have to clean this data, and cannot be clean this data before applying this coding for cleaning the data. And applying this coding, we will extract this clean data with 4 columns: interval, xmin, xmax, and word. The third step is splitting and tokenizing the data set. For splitting, of course, we will take the xmin and xmax as an x-axis, and we will take the word as a y-axis. For tokenization, we have 2 advantages from tokenization. The first advantage is we will reduce the number of the word because we have more than 21,000 words, and we need only the unique words. At the next point for tokenization, we will apply the tokenization for the word column. That means it will encode or convert this word into numeric in order to fit this word in the model later. And then we build our model. The first model, which is RNN model. We build the model And then we use early stopping function, this to overcome the result, to reduce the overfitting of the result. And then we fit our model, the data set, into our model. And it can be seen that this is the best accuracy, which is 3.7 for the loss and 1 for the accuracy. And it's not a good accuracy as expected. And this is the visualization of the model. And it can be seen that there is a big overfitting for the model of the accuracy and also for the model of the loss. We use another model, DNN. We build the model and we use early stopping function in order to reduce the overfitting from the model. We fitting our model, data into our model, and then we visualization our model to see the accuracy and the loss. And it can be seen that there is a big overfitting in the beginning of the model, either in the accuracy or in the loss. And the accuracy, it is 16 for the loss and 1 of the accuracy. And this is not a good result. For the result, with the DNN result, it's not good as expected. It is 70, around 70 with loss and 1 with accuracy. And RNN result is better than DNN, but it is still poor because the loss, it's more than the accuracy with many times 3.6. For the conclusion and future work, this research represents 2 models, RNN, recurrent neural network, and DNN. And this model to predict the world based on X mean and X max value. And there is a mean enhancement in this project, which is the data preprocessing. And it can be seen that RNN model shows best result or better result than DNN model. And this is because RNN, it's more suitable for using or for dealing with time series and expected words. It is highly recommended for other researchers to use another model or to replace loss and accuracy function in a compile function, or to change the data set in order to come up with other results. And the tool that we use in this project, of course, the TensorFlow. It's a library for deep learning, and our language is Python, and also Keras and Scikit-learn to build our model and to make it easy for us to split the model and so on. And this is my project. I really appreciate that you listen to my project, and Assalamu alaikum wa rahmatullahi wa barakatuh.